Hello again, this is Mike with Toy Train Tips and Tricks, and we're working on the new layout. And so far, we've painted the walls, we've built the benchwork, we've laid the track, and now we have basically one more step to get the trains running, and that is to wire up the layout. So in this video, I'm going to be covering one, how to attach the wires to the track. Number two, where to attach the wires to the track. And thirdly, how to wire up the transformer for simple operation. I'm going to handle more complex wiring and blocking and things like that in a later video. In this one, we're just going to keep it simple. We're going to cover the basics. This would be a good spot for beginners to jump in, and maybe more experienced modelers might pick up a trick or two from this as well. So first, let's look at how to wire up the track without using any type of soldered connection. And the basic way to do that with tubular track is with a track lock-on. Now there's a wide variety of these out there, different manufacturers. This is the traditional Lionel CTC lock-on. This is a Marx. This is another Marx. And this is a K-line that works both for O27 and also the outer blade here also connects if you have standard gauge or wide gauge track. It works for all of those. But the lock-on, it's a simple idea. The Lionel and K-line version, all you have to do is line it up with the outside rail and attach this little springy clip to the middle rail, boom, and you are set. And if you notice the contacts, number 2 here goes to the outside rail. Traditionally, we would wire that up as the common for the layout. And number 1 goes underneath and connects to the center rail, and that would traditionally be our hot. Now, if you have a simple loop layout, does it matter which wire goes to which side? With AC, no. On a simple layout, it does not. However, as you get more complex, if you start using multiple transformers, if you start adding certain accessories to the layout, it becomes more and more important to standardize. And so that's when it becomes more important that we keep the outside rails as the common and the center rail as the hot. The Marx lock-ons work a little bit differently. Here we have these blades. You see the Marx logo there. These blades that slide under the track, and this works for both O and O27. And it goes into the slot right here on the bottom. You see the slot right here on the bottom of the rail, and you just take it and you push it. Can you see this? You just push it into the slot, and it is connected. And then again, you can see here from the wiring, when you go to the one here on the left is connected to the outside, the one on the right to the inside. So the opposite of the way the Lionel is wired up. This one outside, inside versus outside, inside. And so these are readily available. You can find them, pretty much anyone who has O27 track is going to have a collection of these. I don't use them, which is why some of these are pretty well corroded. These come in boxes of things that I order on eBay and such. If they're corroded like this, do yourself a favor and don't use these. That's going to interfere with your electrical connection. That's going to add resistance to your circuit. Your train's not going to work as well. Make sure you use, some that are nice and bright and shiny, like these, would be better. So the cleaner, the better. If it's corroded, you can clean this up with rust remover and such, but really, these things are so readily available, it's probably not worth your time and effort. Another way you can power your track is through pieces of track that already have connections to the track. In this case, we're looking at a number 6019 uncoupling track. I have rewired this from the original. Originally, this would be a 4-wire ribbon cable that attaches to the control box. In this case, like most of them that I come across, the original wires were pretty well shot, so I rewired this, and in this video up here you can see how to do that. So here in the 6019 with the 4 wires, if I choose to wire this to transformer power instead of track power, then the hot wire and the ground wire that normally would connect to track power and to track ground become extra wires that I can then use as power hookups. So in this case, and if you watch my video, you can see what each of the 4 wires does. But the blue wire here attaches to the common. It attaches to the outside rails. And its original purpose was to pick up common power and run it in for the electromagnet and the rails. And then similarly, this red wire attaches to the center rail. And again, the idea was that it would take track power, feed it through to the control box, and then pushing buttons would distribute it to the magnet and the appropriate rail. And in this case, the orange and the yellow wire are attached to the appropriate magnet and control rail for whatever the application is. So what I can do if I'm using this 6019 uncoupler is I can attach my track common, the outside rail, just wire that in with my blue wire, and my power, my track hot, to the red wire. And without using any type of lock-on, the power feeds through the electromagnet here in the 6019 track. Now, the later uncoupling tracks that just have the single wire or 2 wires won't work for this. This only works with the 6019 or with the O gauge UCS that have the 5 rails and the appropriate 4 wires. And again, if you visit that video that popped up here just a moment ago, you can see how this wiring system works. And that's another way to tie in the power without having to solder anything to the track. Yet another way that you can power your rails without using lock-ons and without soldering anything to the track itself is by using these K-line remote turnouts. Now you see here these K-lines have 5 posts. Most K-line remote turnouts have 5 posts. I say most because actually right over here is an example of the exception to the rule. This one has 4 posts. We'll talk about that one in a moment. But the most common with 5 posts, these can be wired up for transformer power instead of track power. And that makes this last terminal extra. And we can use that not to pull power from the center rail for the switch motor, but actually send power to the center rail from the transformer. And so to do that, what you'll want to do is you'll want to disconnect this little bridge piece. So we're going to unscrew this nut, and you can actually completely remove this if you want. But basically, you can just slide it out of the way and tighten back down as long as these two are not making contact. So like I said, you can totally take this off and remove this plate completely. But this post goes to the center rail. This post goes to the outside rails. This post goes to the hot side of the switch motor. And then these two go to the ground side of the switch motor to throw the switch left or right as appropriate. So if you want to use track power, you reconnect the bridge. Power goes from the center rail through this post, and through the switch motor. So if you're, again, using accessory power for your turnouts, this then can feed power. You attach your track hot to this post, your track common outside rails to this post, and it feeds power into the turnout. This 4-post K-line is missing the connection that goes to the outside rail. This turnout must be powered by accessory power feeding into here. So you can feed your common to your track still using this post, but on this particular turnout, you cannot feed the hot side to the track, you would need a separate connection for that. Similarly, Lionel's with the 3 posts, you can use the common on the turnout to power the outside rails as well as the turnout. But without modifying the turnout, you cannot feed power to the center rail. So those are 3 methods: the lock-on, the uncoupling track, and the turnout, where you can attach your wires without adding anything else to the layout. Now, another method that I use, and this is the primary method that I use, involves a little bit of soldering, but not soldering connections directly to the track. Because of the coating that they put on the track and the size of the track, it becomes a huge heat sink. So it can sometimes be difficult to solder wires directly to the tin plate track. The track just soaks up the heat and it becomes hard to get a good solder connection. So a good way to make a physical connection, I purchased for a lot of projects at Harbor Freight this collection of different terminals. And what I find works really, really well for the track is this right here. This is a male quick connect. And you see the flat post here, now inspired by the Marx lock-on that uses the blades that go onto the track. I first take 2 of these, solder my hot lead to one and my common lead to the other. And then I come to my track and using a slotted or a flathead screwdriver, just push the rails apart just slightly. And sometimes this takes a little bit of oomph. And then with my wire attached, take the blade and push it into the slot in the track. And this one is being stubborn. These are usually not so hard. There we go. And I can push that in, and it makes a very strong physical connection. When I pull the screwdriver out, this is not going anywhere. And so my wire is attached without a solder connection. Now, if I'm worried about maybe this coming loose, I might try to put a dab of solder on to the blade there just to hold it in place. But do one to the center rail, do one to either outside rail. Now, the downside to this, of course, is then when I put it on the layout, I need to mark the locations and drill holes appropriately so that this will fit down through the layout. If you just bend this over, it is generally too tall. It is taller than the track tie. On O27, if you do this with standard O, with the taller track tie, you have more clearance. But with O27, the wires get in the way and actually raise it up. So in that case, you have to measure out where are my holes going to be when I put the track in, drill my holes, and then run the wires through the bottom and plant the connectors through the holes. And that is a good way to connect the wires so that they cannot be seen. And now the question of, where do I attach wires to the track? Now that I know how to do it, where do I do it on the layout? And even a simple oval can benefit from having multiple power feeds to the track, as you can see in this video, where I did it with a Christmas layout. So on my permanent layout, my rule of thumb, there's no hard and fast rule, but keeping in mind that every time you connect 2 pieces of track, there is an opportunity for voltage loss. There is an opportunity for corrosion or rust, or paint or oil or goop of any kind to get into the track connection and increase the resistance to the circuit, which reduces the available voltage to your motors. So every time you have a track connection, every piece of track provides the opportunity for loss of voltage. So keeping that in mind, you want to have feeders every so often to even out the flow of electricity across the layout so you don't have hot spots and cold spots where the train speeds up and slows down. Now, it's going to do that a little bit naturally in curves because of friction, but you can minimize that as much as possible by having consistent electrical flow throughout the track. So what I do, my rule of thumb, is I want to drop a feeder no more or no less than once every 5 pieces of track. So if I have a long straight that is 7 or 8 or 9 pieces long, I will want to put a feeder on either end of that, or 2 roughly, to divide it into thirds, so that I'm not going more than 4 or 5 pieces of track without a feeder line. The other consideration is if you're using a more complex block control system is, of course, having a feeder for each and every block. So in this example, I would have this section of track would be separate electrically from this section of track and this section of track and this section of track. So I need to have separate electrical feeders for this section, for this section, for this section, and one of these I designate having power for all of the turnouts as well. So that's my other consideration. If I'm doing a more complex block control system, obviously I need a feeder for each block, or even in the case of a simple oval, I want to have an electrical feeder no less than once every 5 pieces of track or so. Okay, so for wiring, what I'm using is what we call common bus wiring. Now, this isn't absolutely necessary if you have just a small layout with a small loop, but really anything more complex than that, this is a real time saver down the road and can save you money as well. And the idea with this is that all of the commons, whether that's the outside rails, the common side of the transformers, the common side of any accessory that you use on the layout, all ties into the same place. And so you see here, I have run an 8-gauge bare copper wire all around the underside of the layout, making a big loop underneath this section of benchwork. And all I have to do for any piece of track, any transformer, anything that is wired up to the layout, for the common side, I just run the wire to the nearest section of this long copper wire, which we're calling a bus, and tie it in there. So I don't have to run the common side wire all the way back to my transformer, all the way back to my control panel. I just find the nearest spot to attach to the common bus, tie in there, and I'm done. So now that I've run my common bus wire under the layout, and I have tied in my track connection, some to the track, some through turnouts. I don't have any uncouplers hooked up on this portion of the layout yet, so I'm not using any of those. But all of the common sides are going to this common bus wire, which will also be attached to the transformer. Now the hot side. Now, if I only had 1 or 2 hot wires for my layout, if I was doing a simple loop, then I could just run those directly to the transformer. In this case, since I am using block control eventually, I run everything to a terminal block like this. And so one side, I run each individual hot line from each individual block on the layout. And right now, since I'm temporarily hooking it all up to one transformer, I just simply use this bus connector on the other side and screw that in so all of them are tied together. Then all I have to do is designate one wire from the hot side and connect the transformer to that, and it is then electrically tied to all of the wires going to all of the different block feeders on the layout. This also works for a loop if you've got multiple drops. Again, you just put the bus on one side. All of your different drops from around the layout can go to your terminal side, which now becomes a bus bar, and it's all conveniently tied to one place. Later on, when I start adding in more transformers for my block control, I will pull this out and then run this side wires each to different selector switches to then choose which transformer is controlling the power to each individual block. And to make sure I remember how I wired everything together, I keep a notebook full of diagrams for wiring and other schematics for the layout. For the wires themselves going to the tracks, you can use typically recommended 18 to 12 gauge wire. The smaller the number, the better, the bigger wire. I wouldn't go smaller than 18 gauge. In this case, according to the markings on the wire, this is 14 gauge wire, which would be sufficient for powering my blocks. Similar, I'm running 14 gauge black wire from the outside rails to my bus wire. All right, so here in this section, I'm using a Lionel CW80 transformer, and you see the red and the black. The red I'm using as the hot, the black I'm using for the common, and these transformers are wired up that way. Most of the time when you have the red and black, it is intended for the red to be the hot going to the center rail and the black going to the outside rail. If you're using a post-war transformer that isn't color-coded, but instead has U, A, B, C, in most cases, the U terminal on a post-war transformer is intended to be common. Not always, but most of the time. Check your individual transformer with old Lionel manuals just to make sure, or you can check it out when you phase your transformer. Black goes to my bus wire right back here, under here. It's about 6 inches back. The red is actually going to the bus terminal on the opposite side of the layout, which because that's where my bigger control panel is going to be. So now all I have to do is turn on the power to my CW80 and power up the lever, and I have power to the track. Turn it down, and away we go. And that's all there is to it. We are wired up, and we are ready to run on my loop with single transformer control to all parts of the layout. And so that's all there is to it. As for this video, we've finished up the wiring, we've got the trains running, and we're going to have some fun. So until next time, keep those trains running, and we'll catch you next time on Toy Train Tips and Tricks.